So residential energy, looking at efficiency first. So I'm basically using my home as the base for this discussion, and what I did follows along, I think, what a lot of other people are going to be doing for looking at getting their house to be more energy efficient and electrifying it. So that path for me was going using my 1927 brick home, which I bought in 1997. It was uninsulated, so I had a lot of work to do with that. The attic was the first place I hit. I blew an insulation up there. We also went right to the thermostat, and I made sure that I had a good setback schedule on it that maximized how much I was at a much lower temperature in the home. We have a pretty good tolerance in our house, so 55 degrees was our standard point when we weren't active in the home, meaning overnight for the most part. And that has grown over the years. So when the kids moved out of the house, now we got it down to 64 degrees during the day most of the time. Also, we upgraded the windows. We had to clean up the existing double hung sashes and redo the weather stripping on them. And then we also removed the old storms and went with a new storm with dull pane windows that we could take the glass out for the summer and put in a screen. And we're at the point where the weather stripping on those storm inserts is wearing out, so I'm actually replacing that. And that was a gradual thing we did over about a 15-year period. Another area where we did some weather stripping was on the, excuse me, recovering from a cold here. On the exterior doors, we have 3 exterior doors on the home. We weather stripped those, and the back door had place where the milk and bread was stored every day when this house was originally built back 1927. And you can see that it was metal and very leaky. So we sealed that up. Well, we insulated it first, and then we sealed it up. And on the exterior of those doors, we had screen doors. They were wood. We replaced them with aluminum screen doors that are well sealed, really stop air infiltration, and do a good job at reducing the amount of heat coming in or being lost out of the building. The next area is we want to do some work in our basement, and as part of that renovation, we changed over half the basement floor plan, where we had to remove the old coal bin, ash bin, and I went ahead and foam insulated the whole wall, floor, and ceiling to cocoon that area to make it comfortable, block out any moisture migration, and also soundproof it, because it was going to be my office where I operated my company out of. And I had young children at the time, and so I wanted to minimize the amount of noise that transferred through the ceiling of the basement. So we did that. Another very common area that people work on is lighting in their homes. The home, when I bought it, was all incandescent. I changed to CFLs almost immediately. And over the years, I've transferred everything over to LEDs. We also installed some motion sensors in the laundry room and in the basement office area that I just showed you. So there's a number of different things or areas that we were able to hit up and address with that. Okay. As part of the lighting, we also utilize a lot of smart sensors. So now this is getting into what the other 2 presenters talked about with electrification and how you can start to minimize consumption. And some future presenters talk about using the GEB to get ahead and integrate it with the utility network to cut down consumption. So we installed these smart sensors or smart stats that allow us to turn on and off lights. You can see here I have them for Christmas lights. I have them for a lamp in the living room. I have them for the master bedroom lamp. And there's also one for a water heater, which I'll talk about in just a little bit here. So with the water heater that we had when we bought the home back in 93, it was a gas-fired piloted unit, 70% maybe efficiency overall. in 98, when we did the renovation of the basement, we had to move the water heater, which was good opportunity to replace it because it was over 25 years old at that time. And we replaced it with a higher efficiency unit. And you'll see that here. It was a forced draft. It was quite noisy whenever that came on, by the way. You can see it sits in the corner. It operated great. We put it on that timer you saw for the smart outlet and turned it off overnight, let it drift overnight. We didn't care about it. So that was not an issue for us. But then I was planning for wanting to go towards a heat pump water heater. So we upgraded our electrical, and maybe after the last two presenters, maybe I didn't really have to do that, but I did. And you can see that we installed a heat pump water heater. It's much larger than the forced draft unit we had before. Went from a 50-gallon to 85-gallon, but much of the extra bulk is due to the compressor and condenser set up on top here. And with this unit, we had to overcome the more expensive gas cost, or I mean, not gas, electric cost, because electricity here in Wisconsin right now is 5 times more expensive than natural gas. Historically, I've been looking at this for probably close to 40 years. It's been about 2 to 3 times more expensive, but it's gotten a lot worse since 2008. It's been as high as 7.5 times more expensive. So that's hard to overcome those energy utilization factors that were just being talked about in the last presentation. The heat pump here was on a list that was shown about 400% efficient effectively compared to the 70% of the original gas heater that was in there. But it's a lot quieter, does cool down the basement a little bit, but that has not been an issue. And the other great thing about it is it does have an app for the phone where, like the smart outlet I had on the older water heater, this one has an app on the phone that I can just turn the temperature down on the unit. It doesn't allow me to turn the unit off overnight, but at least I get down to 110 degrees, and it's there most of the day except for early evening. I have it come up to 123 degrees, and I may have to rethink that after the last presentation. But it comes up 123 degrees for 4 or 5 hours, so we get done with a lot of things we do in the house at that time of day. But when I consider that the heat pump water heater dehumidifies the basement, which allows me to eliminate my dehumidifier, it does save me a little bit of money. It saves quite a bit of energy over the course of a year. So it's a net win from that perspective. The next step is Energy Star appliances. So whenever we're looking at a new device in the house, we look for Energy Star rated equipment. So we have refrigerators. We've done this a couple times since we bought the house. Water heaters, clothes washers. We've gone to a front load that's much more efficient on both heating the water and also use of water. And we haven't done the dryer yet. I still have a 1984 dryer in the house. It's operating very well, and it's actually got a very low consumption because we don't use the dryer all that much. It's only 31 turns per year, or less than $30 it costs per year. Dishwashers, Energy Star. The dehumidifiers, which I no longer need, were Energy Star rated, and our stove and or range, you want to call it, is Energy Star rated. But it's the electric resistance, which takes me to the next step, which we're looking at. And I just got over the holidays here. I got a present of an induction cooktop, and I'm learning how to use that to cut down on the energy use of my stove top. That takes us to the big consumer of the household, which is our heating cooling systems. When I bought the home, it was a condensing furnace, so it was already high efficiency, 90% plus. And however, it had some problems. It needed to be replaced shortly after 2010. So in 2013, we replaced it with a little bit more energy efficient furnace. And the added benefit of that is it had a variable speed fan on it. It was ECM fan motor. That really was the major driver for the purchase the more expensive unit, because it saved me an extra $100 a year in electrical costs on the fan. That too has a phone app. So you see a common theme here is a lot of these newer technologies are coming with these apps that you have on your phone that you can control them And hopefully at some point you can pull out together in like a Google app and be able to control from one location. So we right away went to cut back on scheduling by using the app. The thing that we didn't have before was the cooling system was not centralized. We were using window bankers or window air conditioning units. And with the new system, we installed a unit that was 16.7 SEER, much more efficient than what any of those window units were providing us. So over the course of the years, we've been doing a little bit here, a little bit there, always driving towards that next level of efficiency whenever we're looking at any type of changes in a home. So the next step for the heating and cooling system is to go to a combined fuel heat pump. And I'm hoping to be able to do that with our existing furnace setup, just to be able to go and put a new coil in that will connect up to a heat pump and be able to get us all electrified for most of the year and have the existing furnace just provide a base load in really cold weather. The last part that we did is install some solar this past fall, and that was 7.7 kW. Orientation's not the best for multiple reasons, but you know, it does have a good payback, still less than 20 years, and it adds value to the home. NREL says that for every dollar saved, you have typically about $20 increase in home value. And Zillow says it's 4.1% increase in the value of your home by adding solar to it. So in conclusion, energy efficiency is not a one and done deal. You got to keep at it, just like with so many things in life. Tackle the items that make the most sense. Don't forget sealing the building envelope, which I have at this point. I haven't forgot about it, but it's still something that I hope to address in the coming days or years here. Always look for replacing existing fossil fuel burning equipment with something that doesn't have to burn fossil fuels. An example of that is I have a plug-in hybrid. So most of the time I don't have to burn fossil fuels to drive someplace, which is a great benefit. And I hope to soon add an EV in the future.